Alright, welcome to my channel. We want to discuss about energy quantization and the wave particle paradox. So these are the topics we'll be discussing: energy quantization, electron volts and kinetic energy, photoelectric effects, Einstein's equation, and then the stopping potential. Alright, so we will start with the energy quantization. According to quantum theory suggested by Max Planck, heat or electromagnetic radiation is emitted in fixed, discrete, or separate amounts known as quanta. Now, the energy of photon we know that is light, all right, of quantum is given by E, that is the energy, equal h. What is h? H is the Planck constant, and it has a value. The Planck constant h is 6.63 times 10 to the power of minus 34 joules second. Now, an f is our frequency. Now, when we have frequency, we automatically have wavelength. From wave, we know that frequency times wavelength is equal to the speed. But in this case, we're not going to be talking about just random speed. We're going to be talking about speed of light. So I'll be changing this v to c. Alright, so frequency now is equal to c over lambda, which is the wavelength. We know that speed of light has a constant 3.0 times 10 to the power of 8 meter per second. So I can substitute this value. We have E equal HF, which is the Planck constant, frequency. Now, instead of writing frequency, I'll write it in this case. So E equal c over lambda. This frequency has changed to the speed of light over wavelength. So it means the energy of photon can either be E equal to HF or hc over lambda. So, and where c is the speed of light. Now, electron in an atom have definite energy levels with definite values like E0, E1, E2, E3, and so on. The energy of the electron could change from one level to another. It can move from the ground state. The ground state is E0, or you can move to an excited state, which can take the value of 1, 2, 3, or it can move from an excited state down to the ground state. So the energy change now will be delta E, which will be En minus E0, where E0 is the ground state, while En is the excited state. Now, the value for N can take definite values like 1, 2, 3, and so on and so forth. Now, changing E also is the same thing as HF. The only difference is we're just talking about electron in an atom. So if it's in an atom, it definitely has different level. It's all the same thing with the energy of the photon, which is HF. Now let's discuss about this formula. What this formula is trying to tell us is the more energy we have, the more frequency we have. Though it means that energy is directly proportional to frequency. I can write E is directly proportional to frequency. The more energy, the more frequency. Now let me ask you a question. What is the relationship with energy and wavelength? Are they directly proportional or inversely proportional? Definitely they are inversely proportional. So the more energy, the less wavelength. The more wavelength, the less energy. So E energy is inversely proportional to the wavelength. Now let's solve some questions. Let's start with this. Let's start with this one. Okay, question 1. Calculate the energy carried by an X ray of wavelength 6 of wavelength 6.0 times 10 to the power of minus 10 meter. Now, constant will always be given to you. We are already given the Planck constant, which is 6.6 times 10 to the power of minus 34 joule second. Please take note of the unit, joule second, and then we have the velocity of light, which is this. So I'll write my constant 6.6 times 10 to the power of minus 34 joule second, and the speed of light is 3.0 times 10 to the power of 8 meter per second. Now we are asked to calculate the energy, calculate E. Okay, so we all know that E equal hc over lambda. You don't need to cram so many formulas. Just know that energy is equals to hf. I know frequency is related to wavelength with speed. Okay, so now we just substitute this value and get our answer. So 6.6 times 10 to the power of minus 34 times 3.0 times 10 to the power of 8 over the wavelength is 6.0 times 10 to the power of minus 10. Okay. Now in this topic, please, we need to know how to do standard form very, very well. This is not the time to teach standard form. So I'm going to take every value that are not 10. Let's take 6.6 times 3.0 over 6.0 times, and let's take all 10. Now, you know, multiplication when it comes to indices is addition, and division is subtraction. So this is minus 34 times, that will be plus, this is 8. Now division means minus, and the value there is minus 10. Okay, so let's find the answer to this. Okay, this is 1 into this is 2, 2 into this is 3.3. So E equal 3.3 times 10 to the power of, now minus 34 plus 8 is negative 26. Minus is positive, plus 10 equals to minus 16. And what is the unit for energy? The unit is joules. So that's all concerning question 1. Now let's go to question 2. An electron makes a transition from minus 3.4 electron volts energy level to minus 13.6 electron volts energy level. We are asked to calculate the value of the loss of energy due to transition in joules. Take note of that. And then we are asked to find the frequency of the emitted radiation. So not to make this video long, I will solve this in the next video below.